Now I'll be working on the last video, which is the last page of the review. We are on number 19. Now I think this is different from the one you have in your packet. I think the one you have in your packet has no power on top of 343, so I'm gonna just solve it without it. Now there's two ways to solve something like this. You would for example, you would like to change this to a logarithm. So remember, log and the base is 7, and the answer of this will always be the exponent, and 343 goes in here. Now my academic, you can do this on the calculator and you can find the final answer. My pre-AP, you know that 343 basically is 7 to the power 3. Now this, use the power rule. So basically you need to try to solve as much as you can without a calculator. Log 7 base 7 is 1, so x is going to be equal to 3. So this is one way to solve it. Remember my regular, you can just type in log of 343 base 7 and you will get the same answer. So this is one way to solve it. My pre-AP, you can solve it in a different way. You can put 7 to the power x is equal to, and you know that 343 is 7 to the power 3, so you can rewrite it as such. So since they have the same base, they cancel out, so x is equal to 3. So if you notice that, if you see that this can be written as 7 to the power of something, this method will be easier for you to solve. This will take longer, but it's up to you what method you want to use. Now let's move on to number 20. Again, in order to solve something like this, now I want you to, maybe this is not very clear, so I'm going to rewrite it. The 1/5 is the base. So every time you have a log and you need to solve it and you can see that the argument is the variable, you can just use the circle method to solve. So 1/5 to the power -1 would be x. Again, my academic, you can show me this work and then you can type this in your calculator to show me the final answer. My pre-AP, you know that every time it's a negative exponent, it means you can just switch the fraction. So x will be 5/1, which is 5. Now let's move on to number 21. Now this is an inequality. Now to solve this one, remember you can, what you can do is, as you can see, this is a two-way also method. You can change it to log, so 2x minus 5 would be smaller than log base 5 of 125. Now remember that 125 base 5, my academic, you can put this in the calculator and you will find that it will be 3. But my pre-AP, you have to show me every single step. So you can write the 125 as 5 to the power 3 base 5. Now this will go down, so it will be 2x minus 5 smaller than 3 log 5 base 5. Now we all know that log base 5 is going to be just 1, so you can just cancel it out. So you will be left with 2x minus 5 smaller than 3. Now my academic, you would have known that right from the beginning because log of 125 base 5 is 3. So you can jump from this step to this step. Now you can add 5 to both sides. 2x smaller than 8, and then divide by 2, divide by 2, x is smaller than 4. So that would be a good way to solve it. Now another way to think of this would be the following. Again, there's another method to use this, but again, it's up to you what you want to use. So let me make some room. Okay, so 5, 2x minus 5 smaller than. Now you know that you can write 125 as 5 to the power 3. 5 and 5 cancels out, so 2x minus 5 is smaller than 3. And you solve it and you get to the same answer where x is equal to 8/2, which is a 4. Or x is smaller than 4. Sorry for that. So now let's move on to 22. 7 to the power 3x is greater than 49. Again, you can change it to log, so 3x is greater than log base 7 of 49. So again, the base would go as a small number next to the log. The power will be all alone, and the 49 will be the argument inside the log. Now log 49 base 7 would be 2. So 3x is greater than 2. Now to think of this, let's think of this on the side, my pre-AP. So log 49 would be 7 squared. 7, those cancel out, so you're left with a 2, and there's where this answer comes from. Now 3x greater than 2, so divide by 3, so x is greater than 2/3. This is one way to think of it. Now another way would be, so let me make some room. Okay, another way would be to, you know that 49 can be written as 7 squared. So those cancel out, so 3x greater than 2. So as you can see, if you notice that this method is much easier, much faster. So if you can see that this side or this side, it can be written as of the same base, it would be easier for you to solve it. Now let's move on to 23. Okay, so this is the power addition and multiplication rule. So this would go up as a power, so log base 4 of x squared plus log base 4 of 2 is equal to 3. Now, as you can see, when there's an addition, it means you can rewrite this as multiplication. So you multiply x squared and 2, and you get 2x squared is equal to 3. Now, as you can see, this is a log, so to solve it, you need to write it as 4 to the power 3 is equal to 2x squared. Now 4 to the power 3 is 64 is equal to 2x squared. You divide by 2, so 32 equals to x squared. Now to get x, you need to square root both sides. So x is equal to plus or minus whatever radical 32 is. So my regular, you can give me this as a decimal. My pre-AP, you can give it to me as 4 radical 2, and it all depends. If it's a multiple choice in decimal, you need to find the decimal answer. So if you want me to review with you how I got that, so let's do it. 32, it's basically 5 2's, so every 2 goes out of the radical. So that's 4 radical 2. You got it? Again, I will be going over this and any of your questions on Monday. So make sure that you watch those videos and be ready to ask me as many questions as you want. So number 24, again, this will go up. So it's going to be log base 4 of x squared plus log base 4 of 2 equals to log base 4 of 3. Now you have an addition, so you can multiply those. Now, as you can see, this is a little bit similar to the previous one. We're going to discuss more how it is different. So let me make this smaller and compare them so you can see the difference between them. Now, the difference between those two questions. This one, you end up with log 2x squared equals to a number. So since there is no log on two sides of the equation, you have to change it to exponential to be able to solve. So you cannot cancel out the logs. No, you have to combine those two logs to one log and then change it to exponential. Now here, when you have log on both sides of the equation, they cancel out. So log 4 is gone. Now, remember, what you need to do is, first of all, you need to combine those to give you one log. And since you have another log on the other side, they cancel out. So you'll end up with 2x squared is equal to 3, divide by 2. So x squared is equal to 3 over 2. You square root both sides because you need x, so x is equal to whatever, plus or minus whatever radical 3 over 2 is, okay? Now let's move on to number 25. So I need to erase those and make some room for me to solve, okay? So let's work on 25. Now this is an e, so you need to use natural log. So the natural log of 5 would give you the exponent. Now remember, there is a base over here which is e, but we do not write it down. So now to solve for x, you just divide by 3. So x is going to be equal to whatever a natural log of 5 divided by 3 is, and it's 0.536. Remember, you always round to the third decimal place. Now this one, remember, if it's a natural log, so there is a base e. To solve it, you have to change it to exponential. So e to the power 3 is equal to x plus 2, minus 2 minus 2. So x is going to be equal to whatever e to the power 3 minus 2 is. You do it on your calculator. Now remember, to get to the e to the power 2, you press second and then ln, which is ln, or the natural log. And the final answer, x, is going to be equal to 18.086. So that's going to be your final answer. Now let's move on to 27. Now remember, to solve something like that, first of all, you have to isolate your exponential. So you start by subtracting 4. So 27 minus 4 would be 23. You divide by 3. So as you can see, I'm trying to isolate my e. So 23 divided by 3 would be a decimal. I'm going to keep it as 23 divided by 3, but you can put it as a decimal. Now remember, to solve this, you need to change it to a log. So the log that I'm going to be using is the natural log because I have a base e. So the natural log of the argument, remember you can put this as a decimal, is equal to the exponent, which is 5x. So you can find the natural log of 23 divided by 3, and then at the end you have to divide by 5. Now ln of 23 divided by 3, you get that answer, and then you divide by 5, you can get that x is going to be equal to 0.407. Now let's move on to 28. You see that this is, again, in addition, so you need to multiply those. So you rewrite it as log base 8 of x minus 3 and x plus 4 is equal to 1. Now you have to multiply x minus 3 and x plus 4. So I'm going to write it down. So it's x squared minus 3x plus 4x minus 12. Those can be added to give you plus x minus 12. Now what I'm going to do to solve this, I need to change it to exponential. So it's going to be 8 to the power 1, which is an 8, is equal to this quadratic equation. Now remember, every time you have a quadratic equation, you have to move this to the other side. So you will end up with x squared plus x minus 20 is equal to 0. Now remember, to solve this one, you need to think of two numbers that would multiply to give you negative 20 and add to give you 1. So two numbers that would multiply to give you negative 20 and add to give you 1. The two numbers are 5 and negative 4. So you put them as such. And then you will see that then the two roots are x equals negative 5 and x equals 4. So these are two possible answers. But remember, to make sure that they make sense, go back and see if they would give you a positive inside the log. So let's see. Negative 5. If I plug this in here, it will be negative 5 minus 3, which is a negative 8. I can never have a negative inside the log. So this is not acceptable. Now let's try the 4. 4 minus 3 would give you a 1, so that's good. 4 plus 4 would give you an 8, which is a positive inside the log. That's good, so that's going to be my answer. X is equal to 4. Now let's move on to number 29 again. If it's a subtraction, it means you need to divide those two. So log, and you put it as a fraction, x plus 5 divided by 8 is equal to log of 2. You see that? So every time there's a minus, you would write those as division, as a fraction. Now since I have log on both sides, they cancel out. So x plus 5 over 8 is equal to 2. You can put this as 2 over 1 and cross multiply. So x plus 5 times 1 is x plus 5, and 8 times 2 is 16. You subtract 5 from both sides, so x is equal to 11. There you go. Now let's move on to number 30. Now you know what? I'm not going to erase that. I'm going to erase those so I will have nothing in my way. So I have enough space to write this. Okay, number 30. Again, the same concept, subtraction. So you need to divide those two. So 5 minus 2a over 3a is equal to 1. Now, again, the difference between those two, 29 and 30, is that you combined those two to one log, and then you had two logs, so you can cancel them out. But on this side, you combined those two into one log, but you do not have a log on the other side, so you need to change it to exponential. So 6 to the power 1 is equal to whatever you have inside the radical, inside the log. Now again, 6 to the power 1 is just 6, so you don't have to have the 1. And then you cross multiply, so 6 times 3a would give you 18a equals to 5 minus 2a. You minus 2a, let me, 1 second. So you need to isolate the a's, so I'm going to add 2a to both sides. So 18a plus 2a is going to be 20a is equal to 5. Now to find a, you have to divide by 20. So a is equal to 5 over 20. You can find it as a decimal, which is going to be 0.25, or you can just keep it as a fraction and simplify it, which is going to be 1 over 4. So both are acceptable. Now I hope those 3 videos helped you guys. Remember, we're going to be reviewing together in class. So make sure that you finish your review sheet and come to class ready with your questions. Study well. See you on Monday.